Welcome to the deep dive. Okay, let's jump right in. We're looking at a pretty high-stakes weather situation for Europe, specifically for the end of October 2025.
That's right. We're focusing on the 27th to the 31st.
And our mission today is really to unpack the risk of a major, maybe even an early season winter storm hitting the continent.
Yeah, and let's get straight to the strategic point for you listening. The most likely scenario, maybe 65 to 75% chance, is actually for, fairly typical, unsettled, mild Atlantic weather.
Okay, so the baseline is normal-ish.
Normal-ish, yes.
Yeah.
But and this is the crucial part. Our analysis shows a significant non-trivial risk, somewhere in the 25 to 35% range of a really high-impact event.
Wow, okay, 25, 35%. That's definitely something to watch, more than a 1 in 4 chance.
Exactly. It demands heightened vigilance.
So the big question for you listening is, what complex factors, these sort of global dominoes, are lining up right now to create this specific high-risk scenario right at the tail end of October? Let's try and unpack that.
Okay, so first you have to look at the bigger picture, the sort of background climate state. The statistics are leaning towards severe weather, partly because of two key things happening higher up.
Higher up, you mean in the atmosphere?
Yeah, way up. First, we're expecting a weak La Nina to develop in the Pacific. That's looking quite probable, around 65% chance. And second, we've got this persistent negative or easterly phase of the quasi-biennial oscillation, the QBO.
Okay, La Nina, I get that has global effects, but hang on, the QBO. Remind us what that is again, and how does it connect to a storm in Europe?
Right, so the QBO is this huge wind pattern, maybe 30 kilometers up in the stratosphere over the equator. It flips direction east to west, west to east, roughly every couple of years.
Okay.
Now, the key thing is this easterly phase, especially when it lines up with La Nina, tends to mean the stratospheric polar vortex, that big circulation of cold air over the pole, is weaker, more unstable.
More unstable.
More wobbly. Exactly. A wobbly vortex is more likely to kind of buckle or stretch, letting lobes of very cold Arctic air plunge southwards towards Europe. It's basically priming the atmosphere.
And you're saying we're already seeing signs of this priming. I saw some model runs suggesting a pretty significant cold shot for Central and Eastern Europe earlier in October.
Yes, that's a key piece of the puzzle. We're forecasting a really strong cold outbreak around mid-October, potentially 10, maybe even 15 degrees Celsius below normal in some areas.
Wow.
And that's what we call a crucial precursor event.
Because it creates that sharp temperature contrast. The cold Arctic air meeting the milder Atlantic air.
Precisely. That sharp boundary, the baroclinic zone, is loaded with potential energy. It's like stretching a massive rubber band across Europe.
Yeah.
It just sits there waiting for a trigger.
Waiting to snap later in the month.
Waiting to fuel a really intense low-pressure system, exactly.
Okay, so the atmosphere is primed, the energy is building, but where does the real uncertainty, the sort of chaos, come into the forecast?
That really comes down to the North Atlantic. It's the main battleground right now. The North Atlantic Oscillation, the NAO, that's the key regulator for European weather. But the signals for it are completely split.
Split how?
Well, you've got those big background drivers we talked about, the QBO and La Nina, pushing things towards a negative NAO. That typically means high pressure blocking near Greenland, which allows cold air to flood south into Europe.
Right, the cold pattern.
But pushing back against that, you've got the local factor of these unusually warm sea surface temperatures in the North Atlantic itself.
Ah, the warm blob persists.
It does. And those warm waters tend to favor a positive NAO, which usually means milder, stormier weather coming in from the west.
So a real tug of war. Global signals say cold, local ocean says mild and stormy.
Exactly. And this conflict is why the big ensemble models, like the European ECMWF and the American GFS, are showing this bifurcation. The possible outcomes are splitting into two distinct camps.
Bifurcation. That sounds like a forecaster's nightmare. If the models are split 50-50, how do you even make a call? You can't just average them, can you?
No, absolutely not. That's the critical point here. If you just look at the ensemble, the average of all, say, 50 model runs, it'll probably show something quite benign, maybe slightly cool, slightly unsettled.
Because it averages out the extremes?
Precisely.
Yeah.
But that average hides the real risk. The key is to look at the distribution.
Yeah.
You see this distinct cluster of model members, maybe 25, 35% of them, that go hard for the cold, blocked, high-impact solution. That cluster represents the real risk we need to monitor.
Okay, so don't trust the average. Look for the dangerous outlier group. Makes sense.
Hmm.
So if that 25-35% risk does happen, what does it actually look like? You mentioned two scenarios.
That's right. Two main ways this high impact potential could manifest. First, there's the windstorm scenario.
Okay.
The highest risk there is probably for the UK, Ireland, maybe parts of Scandinavia. We'd be looking at a very rapidly deepening low pressure system, an extratropical cyclone.
The kind that undergoes bombogenesis, explosive deepening.
Potentially, yes.
Yeah.
That could bring really damaging winds, Beaufort force 8, 9, maybe even 10 or 11 in exposed areas. Significant disruption.
Okay, that's scenario one. What's the second?
The second, and maybe the one with bigger economic ripples, is the cold outbreak.
And where's the focus for that?
Primarily Central and Eastern Europe. In this setup, you get stubborn high-pressure building and parking itself over Greenland or Scandinavia, a big block.
Right, the negative NAO signature.
Exactly. And that block just opens the freezer door, allowing Arctic air to pour south persistently. We could see temperatures 5 to 10 degrees Celsius below normal for several days, widespread frosts, possibly early snow even at lower levels.
And you mentioned economic ripples. I assume that relates to energy.
Absolutely critical vulnerability there, because of that blocking high pressure pattern, it often brings very calm conditions,
Yeah.
very light winds.
Ah, so low wind power generation.
Exactly. It can lead to what the Germans call a Dunkelflaut, a dark lull. Wind power collapses. Maybe solar is limited too if it's cloudy or the days are short.
Just when everyone needs to turn the heating up because it's 10 degrees below normal.
Precisely. So you get this double whammy, plummeting renewable generation right when heating demand spikes. That puts huge stress on the grid, forces reliance on expensive gas, and can cause energy prices to skyrocket.
Okay, so summing this up strategically, the specific outcome for late October is still pretty uncertain, mainly because the NAO is so hard to predict right now.
Confidence is low on the specifics, yes, which means the focus has to shift entirely onto really vigilant, proactive monitoring over the next week or two.
And what are the absolute key indicators you'll be watching? What should people look out for in the charts?
Two main things. First, persistent negative trends in the NAO index forecasts. If we see that consistently pointing downwards, that's a warning sign. Second, and maybe more visually obvious on the weather maps, is the development of strong positive height anomalies. Basically big ridges or domes of high pressure building over Greenland and Scandinavia on the 500 hectopascal charts.
Right, the 500 HPA level, about 18,000 feet up, showing the main steering currents. That's the classic signature of that cold-inducing block setting up.
That's the one. If we see that locking in place in the medium range forecasts, the alarm bells start ringing louder.
Okay, so a final thought for you to mull over this week. We know these situations can be volatile. Think about historical storms, like the Great Storm of 1987 in the UK, which was famously under forecast and then exploded in intensity right before hitting.
A classic example of explosive cyclogenesis.
Right. So the question is, even if the forecast stays sort of moderate, what contingency planning needs to be happening now for the possibility that this thing rapidly intensifies in that final 24-48 hours before impact? Something to think about.